Hello everybody, welcome you all to the Robotic Systems PIC Microcontroller video programming tutorials. Before you start, please do install the software that you get in our CD, Micro C Pro for PIC and PIC Simulator ID and WinPIC. Now let's get started. First let's start the LED blinking program. Double click on the Micro C icon that you find in the desktop. You'll see the Micro C Pro launch. The Micro C is a very nice IDE with and very user friendly, and it has got nice cool features. There you see this is IDE, and I'll be explaining all the tabs and all the menus that you will be having here. So first let's start a new project. Go to project, new project. You'll see the project wizard launch. Go to next, and here you can choose the microcontroller that you're working with. Now we are using PIC 16F84A. Please select it and go to next, and here you can select the device clock. I'm going to use a 10 MHz crystal, so I'd better leave it as it is. And if you're using 20, you put it as 20. If you're using 4, put it as 4. Then click next. Choose the location for your project here. I've created a folder called as Micro C in my desktop, so I'm going to store my files there, and I'm going to open another new folder. Will be LED blinking, and the project name will be LED blinking. I'm gonna save it. Next, finish. You'll see the default void main block generated. Before I start before we start programming, let me introduce you to the PIC Simulator IDE. PIC Simulator IDE is this oceans of PIC Simulator. This is a trial version that you get on a CD. Please double click on it to start. You'll see this message. Click OK, and this is the PIC Simulator IDE. You could access all the registers, see what's happening inside PIC, and a very good simulator. Alright, you got first go to options and go to select microcontroller. You will see a list of microcontrollers. This is mostly for PIC 12F and 16F series, and we are going to use PIC 16F84. Do not worry, PIC 16F84 is almost the same as PIC 16F84A, except that 84A is the better, is the latest version. Click 16F84, click select, and then go to options. If you have this compact microcontroller view checked, please uncheck it, and then go to tools, microcontroller view. There you go, you see the microcontroller. Now let me explain this microcontroller to you. PIC 16F84 or PIC 16F84A has two ports basically, port A and port B. Port A has 5 pins, as you see. RA0 to RA4 is the port B, and RB0 to RB7 is the port B. And also you have the power supply, VSS and VDD, and you have MCLR. MCLR is something specific to PIC. You have to pull it high with the 10K resistor in order for the program to start running. And this is the clock oscillator, where you give the clock pulse input. Remember, we selected 10 megahertz while we were setting up the project. That is what the 10 megahertz crystal will be connecting it here. And you have this project settings here. You can go and edit your project settings anytime. Also you have the code explorer. If you have some functions and global includes, you can just select it, access it easily from here. And you have the library manager, where you have lots of cool inbuilt C libraries, hardware libraries, and you have the routine list. You have the project manager, where you can manage projects, manage files inside the projects. Yeah, coming back to the PIC microcontroller, this is a simulator IDE. RA0 port A in any PIC microcontroller will be usually contain analog to digital converters, internal analog to digital converters. Port B is as a digital port. You can use it either for digital input or digital output. Also, the analog port A can be used for digital signals as well. You can also configure it to work it as digital inputs or digital outputs. Alright, that's it about that's a brief introduction about PIC microcontrollers. Now let's start programming. When you start the program, you will get a default void main block. That is where the main block is where the code runs in any C program. That is where the code is being executed. So let me what is my objective here? I'm going to make the port B LED blink, on off. So my requirement would be I am going to define port B as output. How do I define port B as output? There is a register called as TRIS registers, TRIS. TRIS is common and can either use, if you're configuring port A, use TRIS A, or if you're configuring port B, use TRIS B. Is equal to 0x000. Now configure port B as output. If you want to configure port B as input, use 0xFF. Now you are wondering why I'm using something weird like 0xFF. We normally use numbers to define. Now let me explain. If you're working on Windows, go to Start, All Programs, you go to Accessories and go to Calculator. Now if you want to view the scientific view, just click View Scientific. You'll get this scientific thing here. So let me put 0xFF. Let me convert it to the decimal number system that we normally use in our daily life. It's 255. Now let me convert it to binary. This is where this is the interesting part. If you convert it to binary, you see, what do you see? You see all ones. That means configuring port B, TRIS B equal to 0xFF will make the port as inputs. Now let me configure it as outputs, 0x00. So put 00 here, click on hex, 00, then click on binary, you get the 0. Alright. Now PIC doesn't have an operating system. Something has to tell the code that it is run again and again. So inside most programs you will see an ever running loop. In this case it's going to be while 1. This loop will run forever. When the code starts running, first the PIC executes TRIS B equal to 0x00. It will see it 0x00, so it makes port B as output, and then it will come here while 1. The code inside this part will be running forever. So let me make LEDs in port B go high. Port B is equal to 0xFF. Here interesting part, what's FF? Now let me do that again, FF. Convert into binary. This will make port B's LED, all LEDs glow. From here, remember this is the most significant bit. RB7 is the most significant bit, it's the upper bit. RB6, RB5, RB4, all LEDs will glow.